In today's class, let's continue to solve additional problems. And today's class will be the last class with respect to the chapter real numbers. So in yesterday's class only we started to solve additional problems from different reference books like S. Chand, R.D. Sharma, Oswald, and your previous year question papers. And these additional questions are very important in the examination point of view. So let's continue to discuss. Please write today's date. It is 25/5/2021. Chapter 8, real numbers. In yesterday's class, I think we had solved 5 types of problems, 5 problems. So let's go for continuing this. Now I'm going to take 6th one. Right. It is find the greatest 3-digit number divisible by 11. Okay. Right. Find the greatest 3-digit number. Find the greatest 3-digit number which is divisible by, or just write divisible by 8, 10, and 12. 8, 10, and 12. Dear students, even in yesterday's worksheet also I had given you one problem like this. Finding the greatest 3-digit number which is divisible by 3 given positive integers. As the number which is to be the greatest number which is divisible by 3 numbers is going to be found out, then that greatest number will be the dividend, and 8, 10, 12, these will be the divisors, which mean that greatest number will be the multiple of these 3 digits. Hence, it belongs to LCM. Got it? Now, let us go for finding the LCM of these 3 numbers. Right. To find out LCM, let me go for using fundamental theorem of arithmetic. According to that, first let us find out the prime factorization of each of these 3 numbers. This is 2 4s are, this is 2 2s are. Next 10 is there. Find out. This is 2 5s are. Next 12 is there. Start dividing this by 2. 2 6 are, 2 3s are. Now let us write the prime factorization of A. It is 2 raised to the power 3. 10 can be written as 2 into 5. Whereas 12 can be written as 2 square into 3. Let's find out LCM. You have to write all the factors that are involved are 2, 3, as well as 5. Take the highest power of each factor. Highest power of 2 is 3, 3 is 1, 5 is 1. Next, multiply. Here 2 cube is 8, 8 5s are 40, 40 3s are 120. Very good. Some of you have already given the answer 120. Aditya, you are right. Hitesh, Vishnu, good, very good. It is 120. 120 is the multiple of 8, 10, and 12, which means that it is divisible by 8, 10, and 12. Even this is also a 3-digit number, but actually we want greatest three-digit number. Greatest three-digit number. That number should be divided completely by 8, 10, and 12. Let's go for finding. Of course, it is 919. 919 is the greatest number. But is it divisible by all the three numbers? So now we have already come to know that 120 is the multiple of these three. Greatest number, three-digit number should also be the multiple of 120. So hence we shall divide 999 by 120. It is. You can go for taking the digit. Which digit can be taken? Yes. Very good. Chirag. Good. Yes. We can go for taking 12 nines up. So 120 nines up. It will be. Will it be? If 129 it will be more than 1000. Can we go for 8s up? Oh, you are telling final answer. Okay. 120 8s up. Here 0 as it is. 12 8s up. 96. Then subtract. You get 9. This is 3. 39. That is in the greatest three-digit number, which is the multiple of 120. Here 39 is extra. Hence 39 should be subtracted in 999. So here I write greatest three-digit number. Three-digit number is equal to, you may write either 128 or greatest three-digit number minus remainder 39. It will be, it is 660. Sorry, 960. Yes, Pratibha, you are right. Right on the conclusion. Therefore, the greatest three-digit number divisible by 8, 10, 12 is 960. Hope you have copied. Now let me go for taking another example. But this time we are going to find out the smallest four-digit number. Right. Now it is 12. Right. Find the smallest four-digit number. Is 12. Find the smallest four-digit number divisible by 18, 24 and 30. 18, 24 and 32. Observe here also the number was here also whatever the smallest four-digit number that we are going to find out is the multiple of 18, 24 and 32. Now whether it belongs to HCF or LCM?
LCM, sir.
HCF. LCM. Nishka, you are right. Vijayalakshmi, you are right. Very good.
LCM of three numbers.
You are right. We should write. Okay. It is LCM. Once I repeat, why it belongs to LCM. See that? Here, the smallest 4-digit number divisible. It is to be divided by these three numbers. That means it is dividend. To get the dividend, we are to get the dividend. So we have to find out the LCM of these three numbers. And don't go for using the misconception that when smallest is there, HCF for LCM, greatest is there, HCF for LCM. In that, it is not in that way. Understand the given statement, and according to that, go for using the suitable concept. As the number, 4-digit number is a multiple of these three numbers, so it belongs to LCM. Right? Let's find out. These are the given numbers: 18, 24, and 32. Directly go for finding their prime factorization. It is 2 9s are, then 3 3s are. Next, take 24. It is 2 12s are. Next, 2 6s are, 2 3s are. For 32, say 2 16s are, 2 8s are, 2 4s are, 2 2s are. Hope that you have got the same. Now you're right.
Yes, sir.
18 is equal to 2 into 3 raised to the power 2. Next, 24 is equal to 2 cube into 3. And 32 is equal to 2 raised to the power 5. Then find out LCM of these three numbers.
288, sir, LCM.
Oh, very good. Now, let us write all the factors. Okay, 2 and 3 are there. Their highest power. Yeah, 2 is 5 and 3 is 2. Now, let me write that here. This is equal to where 2 raised to the power 5 is
3 to the power 3, sir. 288, sir.
Oh, you are right. It is right. 2 raised to the power is 2 raised to the power 5 is 32. Here only we have 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. Into 3 square is 9. Now 32 9s are 32 10s are 320 minus 32, it is 288. On multiply 9 2s are 18. Carry 1. 9 3s are 27 plus 1 28. 228 is the LCM of the given numbers and is also the number divisible by these three numbers. But it is 3-digit. We want the smallest 4-digit number. Then which is the smallest 4-digit number? Sumed V. Acharya.
1000.
1000, sir.
1000.
1000. Yeah,
1000, sir.
you are right. It is 1000. Just look at it. You must stop writing. Observe the book. The smallest 4-digit number is 1000. Then let's go for finding the dividing this by 288. So how much are
3 are
3s are? When you take 3s are, it will be 3 8s are 24. 2 is the carry. 3 8s are 24 plus 2 26. 2 is the carry. 3 2s are 6 plus 2 8 864. Subtract 10 minus 4 is 6. 9 minus 6 is 3. Then here 9 minus 8 is 1. 136. Will you go for subtracting 136 in 1000?
yes, sir.
Yes, sir.
No. If you
Adding, sir.
subtract,
Add, sir.
no. I'll
Adding.
tell you. I'll tell you. Observe. If you subtract 136 in 1000, again it will be 3-digit number. If you add 136 to 1000, it will be 4-digit number, but not the multiple of 288. So we have 288 threes are. Next multiple is 288 fours are. Hope that you have understood.
Yes, sir.
Yes, sir.
Okay, now you write.
Sir, 1 second.
Once I tell you that smallest 4-digit number. Before writing this, once I tell you. Okay, observe. Here we got the LCM of the given numbers, that is 288. This is the multiple of given numbers, but we want smallest 4-digit number. Here we have 3-digit number. To get smallest 4-digit number, so it should be multiplied by a suitable number. If you take, see that if you take ones are 288, twos are, it is more than 500, threes are, it is more than 800. The next multiple is fours are. Hence, that should be multiplied. 288 into 4. So 288 into 4. Multiply it. 4 8s are 32, 3. 4 8s are 32 plus 3, 35.
1152.
3. 4 2s are 8, 8 plus 3, 11. Very good. Some students have already given the answer. You are right. It is 1150. This is the smallest 4-digit number and is the multiple of given numbers 18, 24 and 32. Or else it is the smallest 4-digit number which is divisible by all the 3 numbers. Right. Siddesh, you are right for writing the conclusion. Therefore, the smallest 4-digit number, divisible by 18, 24 and 32 is 130. So it is 1152. So these are the problems to be asked in the examination for 2 marks. Now we have another last type problem is there. It is with respect to the first part of this chapter. That is, you all know that how to express the odd positive integers and even positive integers in the particular form, right? So let's go for taking the problems on this time. I'll rub it. Dear students, please don't go for writing anything, just keep observing. We are very familiar with even numbers as well as odd numbers. Number which is divisible by 2 is even, which is not divisible by 2 is odd. They are in the particular form as well. If I write even number as 2q, Sumit V. Acharya, then how can we write odd number?
2q
3q.
2q
2q minus 1.
q plus 1.
2q plus 1, 2q plus 3.
2q plus 1.
2q
Right.
plus 1. 2q plus 3.
Similarly, if I write 4q,
4q plus 1.
4q plus 1.
4q
q
plus
plus
1.
3.
4q plus 3.
enough. You are right. It is 4q plus 1, 4q plus 3. Similarly, if I take the even number as 6q.
6q plus 1.
Q plus 1.
2 plus 5.
Wait. 6q plus 3, 6q plus 5.
5.
Right? These are the possible ways. And it depends on whatever the divisor we go for taking. Other than this, suppose a number is divisible by 3. If a number is divisible by 3, what will be the possible remainders?
0, 1 and 2, sir.
Yes, 0, 1 and 2. Then if I write that number as 3q, the next number will be
3Q plus 1, 3Q plus 2.
3q plus 1. Next number will be
Q plus
3Q
2 plus 2.
plus. If a number is divisible by 5, then
0, 1, 2, 3, 4.
0, 1, 2, 3,
0,
4.
1, 2, 3, 4, 5.
when a number is divided by 5, the possible remainders will be 0, 1, 2, 3, and 4. Then the consecutive numbers will be, one is 5q, next one is
5Q plus 1.
1. Similarly, 5q plus 3, 5q plus 4, right? So these are the possible ways. So keeping these things in our mind, let's go for solving some important problems which had given in the examination for 2 marks. I'll take very first one in that. I think it is 13th one. Right. 13th one. 13th one. Right. Prove that if x and y are odd positive integers, if x and y are odd positive integers, then x square plus y square is even, but not divisible by 4. But not divisible by 4. Hope you have copied.
Yes, sir.
Okay, now observe. See that it's very general thing also. Even you have come across different pattern of numbers in your previous classes. There also you had learned the statement like this, but there you had not proved. But here we are going to prove it. Once you go through the statement, it is prove that if x and y are odd positive integers, there are 2 odd positive integers, then we have to show that then x square plus y square is even but not divisible by 4. I go for taking any 2 positive integers. So any 2 odd positive integers. Let's take 3 and 5. Look here. These two are x and y, odd positive integers. Then x square plus y square. That is 3 square plus 5 square. Where 3 square is 9, 5 square is 25. 25 plus 9, it will be 34.
34.
34. Is it even number?
Yes, sir.
Yes. Is it
Yes, sir.
divisible by 4?
No, sir.
No. That is only. But we have to prove this statement with logical steps. This is practical. Just by taking 3 and 5 as odd numbers we have shown. Let's go for proving the statement with logical steps. Right. Prove. They only have given x and y are odd positive integers. Right. X and y are odd positive integers. But we do not know what are these odd positive integers. Whether it is 2q plus 1, whether it is 4q plus 1, 4q plus 3, or 6q plus 1, 6q plus 3, 6q plus 5. We do not know that. But in general, we know that any odd positive integer can be expressed in which form?
2q plus 1.
2q plus 1, right? If it is even, generally we write 2q. If it is odd, 2q plus 1. So let us use that known knowledge, right? We know that an odd integer is of the form 2q plus 1. 2q plus 1. But how many odd integers are there?
Two, sir.
Two odd integers are there. One is x and another one is y.
Y.
Dear students, please do remember. Here we have taken 2q plus 1. You may also take even 4q plus 1, 6q plus 1, 8q plus 1. See, they are all odd numbers only. Here we have two odd positive integers. Hence, I take x as, see, in this form. That is 2m plus 1. And another one is x equal to, sorry, y is equal to 2m plus 1. Where m and n are some integers. Hope you have understood. Observe.
Yes, sir.
Did you understand?
Yes, sir.
These are the two odd positive integers, and we know that odd positive integers can be written in the form 2q plus 1, 4q plus 1, 8q plus 1, 12q plus 1, 24q plus 1, and so on. But in that, we have taken this form 2q plus 1 as two odd positive integers. Let us write each of them in this form. Hence, I have taken x as 2n plus 1 and y as 2n plus 1. Now, let us find out x square plus y square. Right. X square plus y square. This is equal to, where x is 2n plus 1, right, whole square, plus y is 2n plus 1, right, whole square. Now, each of these two terms in the form a plus b whole square. So, expand that identity. It is a square plus b square plus 2ab. Shall I write the value directly?
Yes, sir.
Yes, sir.
2m a square, 2m whole square. It is 4m
Times 4
square
plus 1 plus 4m.
plus 1 whole square is 1. 2ab, 2 into 2m into 1, 2ab.
4m.
2 to the 4, 4 ones are 4. It is 4m plus 2n plus 1 whole square. It is also in the same form. That is a plus b whole square expand. 2n whole square is
4n square.
4n square. 1 square is 1
1.
plus 2 into 2n into 1. 4n.
For answer.
Hope you have understood.
Yes, sir.
Yes, sir.
Sir, why you done squaring?
Yes.
Why you done square, sir?
Tell loudly.
Sir, why you done square? Square, sir.
Here x square is there. Here y square is there. We have substituted. Then we have applied a plus b whole square. A square plus b square plus 2a. Got it? Did you understand?
Sir, why you done square, sir?
Hmm?
Square, why you took, sir? X square, why you took?
Because here it is given. See that? We have to show that x square plus y square is even and is not divisible by 4. We want x square plus y square. That is why we have taken x square plus y square. Hope that you have understood. Okay. Now, let me continue this. Please go on writing with me. Here, 4m square is there. 4m square. I'll write it one time as their square term. 4m square plus 4n square. Next, write m term. 4m plus 4n. 4m plus 4n. Next, 1 plus 1. This is 2. Yes, students, observe the first 4 terms. In these 4 terms, you can
4 is
come to know
4 common.
4 is the common factor. It is 4 into m square plus n square plus m plus n plus 2. Follow? Look at, is it even number?
Yes, sir. It is on the form
Yes, sir.
4 plus 2.
No. Observe it. Look at the word here. Of course, it is even number. If it is even number, it should be divisible by 2, right?
2.
Even when you take 2 as the common factor, just don't go for striking out your writing. Just to make you to understand, I am writing one more step. If I take 2 as common factor, it will be 2m square plus 2n
square.
plus 2m plus 2n plus 1. Got it?
Yes, sir.
Yes, sir.
Now, can we say that it is the multiple of 2?
Yes, sir.
If
Yes,
it is
sir.
the multiple of 2, then it should be divided. It should be
Even
divided
number.
by 2 also. If it is divisible by 2, then what type number it is?
Even
Even
number.
number.
It is even number. So you write this step. Write down this step. 2 into copy this. 2m square plus 2n square plus 2m plus 2n plus 1 is divisible by 2. Therefore, it is even. Overall, written
Yes, sir.
Yes, sir.
Yes, sir.
x square plus y square can also be written as. Now, I'll take 4 as the common factor. 4 into m square plus n square plus m plus n plus 2. Okay. From this statement, we can understand that when you divide this number, that is x square plus y square by 4, it leaves the remainder 2. Got it?
Yes,
You
sir.
understand? The meaning of this statement is when the given number is divided by 4, you get 2 as the remainder. If 2 is the remainder, then do you say that it is divisible by 4?
No, sir.
No, sir.
No, it is not divisible by 4. Clear? From this, therefore, it leaves 2 as remainder on dividing by 4. Hence, we can say that x square plus y square is even. See that this is from this. It is even and is not divisible by 4. Even and not divisible by 4. Should be practiced this type of problem. Hope that you have understood this. It was given in the examination for 2 marks. Please do remember. Again, I have been reminding you that it was given in the examination for 2 marks.
Good morning, everyone. Sorry for the disturbance. Some students, they turn on their video and they keep the mobile somewhere. So we have to see you. Please keep your mobile properly, your opposite side. We have to see you. I'm requesting you all, please keep your mobile, your opposite side. Thank you.
Your students, really our technical department is doing very good. It is all, these all efforts either from parent side or from our side. It is for your sake only, for your betterment, for enhancing your knowledge. Please make use of our effort. So technical department just it has reminded you that please turn on the video. Those who have not turned on the video, please do that. And second thing, you have to place the mobile with a comfortable distance such that your face should be visible to us. That is our technical department. As you come to 10th standard, self-awareness is important. We cannot force anybody to get highest score. You must have good intention to score highest. Yeah. Okay, now let me go for taking another one of same type. Right. It is 14th one. It was also given in the examination. Show that one and only one out of one and only one out of n plus 2, n plus 4 is divisible by 3. Where n is any positive integer. Okay. Hope that you have copied. Once we check the statement, show that one and only one out of n plus 2 and n plus 4 is divisible by 3, where n is any positive integer. Okay. Go to the statement. There are 3 numbers n plus 2 and n plus 4. Out of these three, only one is divisible by 3. If n is any positive integer means it may be either even number or even positive integer or odd positive integer, right? But we do not know what are those positive integers. It has been clearly given that out of these three, one is divisible by 3. That means those three numbers can be
Odd
divided
positive
by
integer.
3. When a number is divided by 3, we know that the possible remainders. What are those possible
0, 1,
remainders?
2. 0, 1, 2, sir.
0, 1, 2.
Very
1
good.
and 2, sir.
Yes, 0, 1 and 2. Right. If 0, 1 and 2 are the possible remainders, then what will be the numbers, consecutive numbers? Very good. 3 cube, 3 cube plus 1. Excellent. 3 cube plus 2. Yes, Sudarshan. Good. So let us go for taking them. Right. Proof. Right. When a number is divisible by, when a number is divided by 3, come on, the remainders are 0, 1 and 2. This is one thing. Next, and we know that a positive integer is of the form. Yes, just you said that it is either 3. I told you that positive integer may be even or odd. We do not know that. Let us go for taking all the possibles. 3 cube plus 1 or 3 cube plus 2. Followed. So n, either it may be 3 cube or it may be 3 cube plus 1 or even it may be 3 cube plus 2. So we have 3 possible cases. Let us go for one by one. Right. Case 1 is when I take n is a positive integer that has 3 cube. Very good. When n is equal to 3 cube. Underline this. We have other two, n plus 2 and n plus 4. Let us find it. Write with me. N plus 2, where n plus 2, n is 3 cube plus 2. Next, n plus 4, n plus 4, where n is, we have taken 3 cube plus 4. And this can be rewritten as 3 cube plus 4 can be written as 3 plus 1. Please understand, if you do not understand anything, get clarification about your doubt. Now here I can write this as 3 into cube plus 1 plus here 1 as it is. Dear students, just observe. Sir, can we write it as 2 plus 2? No. Siddesh, you cannot write 4 as 2 plus 2 in this case because here 3 is there as the divisor. Means it should be written in the form of 3. That is 3 plus 1. Observe it. First one, n equal to 3 cube. It is divisible by 3. Sorry, explain from one case one. Okay, I'll explain that. Listen carefully. Look here. N plus 2, n plus 4. There are three positive integers. Out of these, one is divisible by 3. When n is any positive integer, we do not know whether n is even or odd. Hence, we have written that 3q plus 1 and 3q plus 2. If you substitute 3q in place of n, then n plus 2 can be written as 3q plus 2. N plus 4 can be written as in place of n, 3q, then plus 4. Here 4 is written as 3 plus 1. In the first two terms, 3 is common factor. It will be q plus 1 as it is. Now observe it. See that here first one 3q, it is multiple of 3. Therefore, it is divisible by 3. Whereas meaning of second statement is when you divide this number by 3, you get 2 as the remainder. So it is not divisible by 3. This one, see that when you divide this number, you get 1 as the remainder. Do you say that it is divisible by 3? Is it divisible by 3?
No, sir.
No. So out of these 3, in which case it is divisible?
N equal
It's
to
1,
N
sir.
equal
N
to
equal to 3q.
Did you understand?
Yes, sir.
Yes, sir.
Okay. Now let's go for taking case 2. Right. Case 2 is when n is 3q plus 1. When n is 3q plus 1. Underline. The next two numbers are n plus 2 and n plus 4. Right. N plus 2, where n is 3q plus 1. Right. Plus 2. Now, this is equal to 3q plus 1 plus 2 is 3. And this can be written as 3 into q plus 1. Can we write so?
Yes, sir.
Sir.
Next, let me take n plus 4, where n is 3q plus 1. Here plus 4 is there. Then 3q plus 1 plus 4 is 5. How do you write 5?
3 plus 2.
3
3
plus
plus
2.
2, sir.
3 plus 2.
Very good. 3 plus 2. In the first two terms, 3 is common factor. Q plus 1 plus 2. Written up. Now, please observe. Okay. The meaning of first one, n equal to 3q plus 1 is, when you divide this by 3, you'll get 1 is the remainder. So it is not divisible by 3. Second one, see that this is multiple of 3. Therefore, it is divisible by 3. In this, in third one, see when you divide this by 3, you'll get 2 as the remainder. Is it divisible by 3?
Yes, sir. No, sir.
Sir. No, sir.
No, n plus 4
No,
is
sir.
not divisible by 3. Out of these 3, see that n plus 2, n plus 4. Only the second one is divisible by 3. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Dear students, now you have to write in here. It is divisible by 3. Call it as statement 1. Next, here. n plus 2 equal to 3q plus 3 into q plus 1 is divisible by 3. Call it as statement 2. Hope you written. Now let's move on to third case. Case 3. Right. Case 3. What is that?
3q plus 2, sir.
When n equal to 3q plus 2. Right. 3q plus 2. We have taken 3q. 3q plus 1 is also over. Now we are taking 3q plus 2. Yes. Right. Next, n plus 2. N plus 2. It is n is 3q plus 2. Here plus 2 as it is. Then 3q. 2 plus 2 is 4. How do you write 4?
3 plus 1.
Very good. Right. 3 plus 1. Now take 3 as common factor. You will get q plus 1 plus 1. Next, n plus, which is next one?
4.
4.
N plus 4. Where n is 3q plus 2 plus 4. It is equal to
3q plus
3q plus 3.
K plus 3.
3q plus
3.
see the 2 plus 4 is
6, sir.
3 plus 6, sir.
You can represent that 3 plus 3.
right.
plus
Right. Very good. 2 plus 4 is 6. 6 is the multiple of 3. You can keep that as it is. You know, write again 3 plus 3.
3 into q plus 2, sir.
Yes, 3 into q plus 2. Now n plus 4 is equal to 3 into q plus 2. See, it is the multiple of 3. Therefore, it is divisible by 3.
3.
Yes, right. It is divisible by 3. You may call this statement as 3. Written up? Written?
Yes, sir.
Yes, sir.
Now look here. Statement 1, statement 2, and statement. With respect to statement 1, out of these 3, that is n plus 2, n plus 4. N is divisible by 3, right? No need to copy it. Now you have to listen to me. I think Adil Malik. Look here. Next one. Among these, look here. n plus 2, n plus 4. N plus 2 is divisible. Among these three, n plus 2 and n plus 4, n plus 4 is divisible. So, from statement 1, 2, and 3, we can conclude that out of n plus 2 and n plus 4, 1 is divisible by 3. So, write the conclusion. Right. From statements 1, 2, and 3, we can say that, or we can conclude that. Very good. With that, Spandanayam. One and only one out of n plus 2 and n plus 4 is divisible by 3. Hope that you have copied this completely. Now I'm going to take another statement which was given in the examination. I'll rub it. Shall I?
Yes, sir.
Right. It is 14. Show that that 15.
15, sir.
Okay. Show that n square minus 1 is divisible by 8 if n is odd positive. N is odd positive integer. Okay. Observe. Hope that you have copied this. Now go through the statement. Show that n square minus 1 is divisible by 8 if n is any odd positive integers. It is also one of the general statement or general pattern which can be proved just by taking few examples. N is any positive, n is any odd positive integers. You may go for taking 3, 5, 7, 9, 11 and so on. Now, n square minus 1. See the 3 square minus 1. It is 9 minus 1. 8. 8 is divisible by 8. Next, when n is 5, 5 square minus 1. 5 square is
24.
minus 1, 20. It is also divisible by 8.
8.
You may go for taking any one. Even 9. 9 square minus 1.
80.
81 minus 1. 8.
Divisible by
80, sir.
80 divisible by 8. Sorry, 8. Is it not? But it should be proved with logical steps. Then, here they are given. Show that n square minus
What is that question?
divisible by 8 if n is odd positive integer. Dear students, you all know that odd positive integers is of the form 2q plus 1 or
2q plus 3.
4q plus 1, 4q plus 3. Please don't write. Listen to me. Then 6q plus 1, 6q plus 3, 6q plus 5. Many are there. Is it not? I go for taking the suitable one. Then could you tell which one can be taken as odd positive integer?
3q plus 1.
2q plus 1.
2q plus 1. Observe it.
Sir, 9m plus 1.
9m plus 1. 2q plus
8
1.
plus 1.
Your students, once I clarify you, you have to take n as odd positive integer. We do not know what is that odd positive integer. I give you some hints. Don't copy, just observe. It is in the form 2q plus 1 or 4q plus 1 4q plus 3, 6q plus 1, 6q plus 3, 6q plus 5. Like that, plenty of numbers can be written. Got it? Then, if you find out n square minus 1, it should be divisible by 8. You know that 8 is the multiple of 2. 8 is also the multiple of 4. Then can we go for taking 4q plus 1 and 4q plus 3?
Yes, sir.
Yes, sir.
Yes. Then should we not take this one?
Can we take, sir?
We can take. Any of these can be taken. If you take first one, you'll get only first case. If you take 4, you'll get 2 cases. If you take this, you'll get 3 cases. Just once you observe, suppose I take n square minus 1, where n is 2q plus 1. 2q plus 1 whole square minus 1. It is of the form
A plus B whole square.
a plus b whole square. A square is 4q square, b square is 1 plus 2ab. 2 2s are 4, 4 1s are 4. 4q minus 1. Minus 1 plus 1 get cancelled. 4q square plus 4q. 4 is taken as common factor. Q square plus q. Okay, 4. This number is the multiple of 4. It is divisible by 4. But can we say that is it divisible by 8?
No, sir.
No. Hence, let's go for taking 4q plus 1 and 4q plus 3. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
See, if 8 by 4 is there, we say that 8 is completely divisible by 4. Right? If 4 by 8 is there, we write just it as 1 by 2. Of course, it has decimal form 0.5. Then do you say that 4 is completely divisible by 8?
No, sir.
No,
No,
sir.
sir.
No. But it can be expressed in the simplest form. Here also. That is why I go for taking 4q plus 1 and 4q plus 3. Right. Then prove directly. We know that the odd integers is of the form is of the form 4q plus 1 or 4q plus 3 for some integer q. For some integer q. Now, let us take case 1. That is, what is n?
4q plus
4q plus
Right. When n equal to 4q plus 1. When n equal to 4q plus 1. Now, let us find out n square minus 1. If I take 4q plus 1 in place of n, we can write like this: 4q plus 1 whole square minus 1. It is of the form a plus b whole square, where a square 4q whole square 16q square plus b square, that is 1 square. 1 square is 1 plus 2ab. 2 into 4q into 1.
8q.
4 by 8. 8 ones are 8. 8q minus 1. Now plus 1 minus 1 get cancelled. You will get 16q square plus 8q. How do you write this?
8
4
into
of
2 square plus
8
2q
is common.
Common, sir.
Very good.
2q square
8
plus
into 2q square plus 1q. See that?
Sir, we
It
can
is
take 4
multiple of
also, sir.
8. If it is multiple of 8, then it is divisible by 8. So we can write is divisible by 8. So you may call this as statement 1. Now you write case 2. Case 2. In case 2, what should be taken?
4q plus 3. 4q plus
When n equal to 4q plus
4q plus
right. 4q plus 3. When n equal to 4q plus 3. Right. N square minus 1. That is equal to where n is 4q plus 3. Your square is there, right? Then minus 1. This is equal to, again apply a plus b whole square identity. A square 4q whole square. It is 16q square plus b square. B square it is 3 square. 3 square is 9 plus
9.
2ab. 2 into 4q into 3.
24q.
Very good. 24q minus 1 as it is.
9 we should write
Repeat
as 8
equal.
plus 1, sir.
Huh?
9 we should write as 8 plus 1, sir.
Oh, no. You are right only, but here only we can simplify that. Observe 16q square plus 24q as it is. What is 9 minus 1?
8.
8. Now can we go for taking 8 as common factor?
Yes, sir.
Yes, sir.
Yes, sir.
Right.
8 into 2q square plus 1 3q.
2q square plus 3q
Plus 1.
Plus 1.
Nishka, is it divisible by 8?
Yes, sir.
Why?
Yes, sir.
Sir, because there is no remainder.
There is no remainder. Remainder is 0 and is a multiple of 8. Therefore, it is divisible by 8. Right. Is divisible by 8. You may call this as statement 2. Now you write from statement 1 and 2. We can say that n square minus 1 is divisible by 8 if n is odd, that is odd positive integer. Hope that you have understood.
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Okay. Now I'm going to take another one. It is also almost similar to this one. Sir, explain second case. Okay. One second. Second case. See, in first case, we have taken 4q plus 1 in place of n. Second case, we should take 4q plus 3 in place of n. The given number is n square minus 1. We have written the same, n square minus 1. Where n is 4q plus 3. Then square is there, we have written minus 1. Now this is of course a plus b whole square. A square, that is 4q whole square. 4q whole square is 16q square. B square, 3 whole square. 3 square is 9. Then 2ab, 2 into 4q into 3. 2 4 8, 8 3 is the 24 into Q 24 minus 1 as it is. In the next step, 9 minus 1 is 8. In the next step, all the coefficients are the multiples of 8. Hence, we have taken 8 as common factor. On taking 8 as common factor, you will get the remainder 0. Therefore, it is divisible by 8. Hence, yes, we can take also common that. And you can also, okay, from statement 1 and 2, you can conclude like this. And another student is asking the question that, sir, can we take 8Q as common factor? Of course, you can take. If you take 8Q as common factor, it will be 2Q. This will be plus 1. Again, it is the multiple of 8 and is divisible by 8. Hope that you have no more doubts. Then I'll move on to the next one. As I said, it is also similar to this statement. Right, 16th one. It is prove that n square minus n square minus n is divisible by 2 for any positive integer. For any positive integer. Dear student, in previous problem, it was given that n square minus 1 is divisible by 8 if n is, what was n?
Odd positive.
Odd, sir.
Yes, it was possible only for odd. But now it has been given that prove that n square minus n is divisible by 2 for any positive integer. Any positive integer means it may be either even or odd. Did you understand?
Yes, sir.
If a number is divided by 2, the possible remainders will be
0 or 1, sir.
0 and 1. Then what are those positive integers? Hope that you can tell.
2Q and 2Q plus 1.
Either it may be 2Q or it may be 2Q plus 1. Right?
Yes, sir.
Yeah, please go for writing. Right. Prove. Proof. Let. On its side. We know that for any positive integer, we know that positive integer is of the form it is I take 2Q or 2Q plus 1. The reason is they are given we have to prove n square minus n is divisible by 2. Hence I have taken 2Q plus 1. For some integer Q. Now, how many cases we'll get?
2 cases, sir.
2 cases.
0.
Right. Case 1. Prem, you tell. Case 1, what should be taken? Prem P. Kaleshwar.
2Q. 2Q.
When n is 2Q.
ಏನು ತಗೋಬೇಕು ಅಂತ
2Q. Write that. It is n square minus n. n square minus n is there, where n is 2q. 2q whole square minus n. n is 2q. It is equal to 4q square minus 2q. What is the next step? Prem,
2Q
Common
common, sir.
factor, 2.
2Q
Yeah.
common.
you may take only 2 as common factor or 2q as common factor. However you want. I take just 2 as common factor. 2 into
2q square.
2q square minus q. See that here, what is the remainder?
0.
0.
Remainder is 0. And can we say that it is the multiple of 2?
Yes, sir.
Yes, sir.
If it is the multiple of 2, then it is divisible by 2,
2.
right?
Yes.
Okay, right. Is divisible by 2. Second case. Second case, right. When n equal to 2q plus 2q plus 1. n square minus n. Even you can simplify and write, or else directly you may substitute. 2q plus 1 whole square minus n 2q plus 1. This is equal. Now it is of the form a plus b whole square. A square. It is 4q square. B square. It is 1.
4q.
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 Minus 2q plus 1.
Minus 2q minus 1. Should be careful while using the sign. Minus should be multiplied with both. Minus 1 into 2q minus 2q. Minus 1 into plus 1 minus 1. Now this is equal to 4q square. Then 4q minus 2q, it is 2q. Plus 1 minus 1 get cancelled. Here, next step. Next step.
2 common, sir.
Taking 2 is common.
Yes, either 2 as common factor or 2q as common factor. Whatever can be taken. 2 into
2q square plus q.
is divisible by 2. Now you may call this as statement 1 and this as statement 2. From 1 and 2. From 1 and 2, we can write n square minus n is divisible by 2 if for any positive integer. For any positive integer. For any positive integer.
Sir, excuse me. Sir, explain once again. Once again.
From where?
Case two.
First case,
Case
second
two.
case.
Case 2.
Case 2. Okay. Here, n is 2q plus 1. In place of n, that should be substituted. N square, 2q plus 1 whole square. Minus n. So minus of n is 2q plus 1. Now this is of the form a plus b whole square. So a square plus b square plus 2ab. A square, 2q whole square is 4q square. B square, 1 whole square is 1. 2ab, 2 into 2q into 1, 4q. Now multiply by minus. So it will be minus 2 cube and this will be minus 1. Minus 1 plus 1 get cancelled. You'll get 4q square plus 4. 4q square, 4q minus 2q, 2q.
Yes, sir.
Then 2 is a common factor. If 2 is a common factor, then it will be 2q square plus q. And as it is the multiple of 2, is divisible by 2. From statement 1 and 2, the given statement is proved.
Sir, I have yesterday's one doubt, sir.
Similarly, nq minus n can be given, and such questions will be given in the worksheet. Now, I'm going to take a last problem from addition. It is the statement problem. Right. Copy this. And it was also given in the examination. The statement was 105 goats. 105 goats, 140 donkeys, 140 donkeys, and 175 cows. 175 cows have to be taken across a river. Have to be taken across a river. Full stop. There is only one boat. There is only one boat. One boat which will have to make many trips. Which will have to make many trips. Many trips in order to do so. In order to do so. First of all, the lazy boatman has his own conditions for transporting them. Has his own condition for transporting them. Full stop. He insists that he insists that he will take the same number of animals. He will take the same number of animals in every trip. And they have to be of the same kind. And they have to be of the same kind. First of all, he will naturally like to like to take a largest possible number each time. Like to take the largest possible largest possible number each time.
Kishan Revankar, are you writing or something, talking with someone? Kishan Revankar, please write down the question. Don't talk or don't do anything.
Okay, sir.
Right. Can you tell how many animals went in each trip? How many? Can you tell how many animals went in each trip? Can you tell how many animals? What? 30. Dear students, hope that you have understood the given statement. It's very simple. Ayush B, you are right. It belongs to HCF only. HCF only. Observe, very simple thing. Here they are given the number of goats, 105. Goats are there, 140. Donkeys are there, and 175. Cows are there. They have to be transported from one place to another place. That is across the river. And the boatman will give a condition that there's this one condition for transporting them. He insists that he will take the same number of animals in every trip and they have to be of the same kind. He will naturally like to take the largest possible number each time. Hope that you have understood. In each trip, whatever the number of goats, donkeys, and cows are to be taken, and same number will be continued in all the trips. Then question is, can you tell how many animals went in each trip? In one trip, how many animals were transported? So as they are to be transported, see, those animals are to be divided into some groups. As it is going to be divided, it belongs to HCF. So you need to find out HCF of these three numbers. Could you tell how much you may get? Some of you are already telling the answer.
35, sir.
35. Very good. 30 won't come. Sudarshan, observe here. HCF of these three numbers. 105 is divisible by 35. 140 is divisible by 35. 175 is also divisible by 35. Clear up? So now just I'll give you the hint. You can do that yourself. In data, you should write number of goats, next number of donkeys, number of cows. Then after that, calculation. In calculation part, so the number of animals to be transported in each case, that's equal to HCF of these numbers. You'll find out the HCF, you'll get 35. Clear? Please don't go for solving now. Listen to me carefully. Here, could you tell in each trip, how many goats were transported?
Yes, sir, we should divide 35 by 103, sir.
You should divide 105 by
35.
3, sir.
Right? 3. Second one?
4, sir.
4.
Third one?
5, sir.
5.
Can you do that?
Yes, sir.
Okay.
Yes, sir.
You may stop writing. Now it is the time for
Sir,
concluding
I
the
have
class.
doubts, sir.
Listen to me carefully. Here today, what all the problems we have done, they are a bit different comparatively the previous periods. So you need to practice them without fail. Please make use of the daytime for working out, and evening I'll give you some more statements as work in case of worksheets. Okay, and with this, the chapter has been completed. So this is enough for the examination point of view. I've made you to solve all the types of questions which are to be asked in the examination. If you go through the reference books, still other types will come. But I have focused completely on your examination point of view. So
Okay, sir.
these are the questions which will appear in the examination. Yes, and Rahil, and to everybody, from tomorrow onwards, we will focus on science. As I said, when one chapter is completed from mathematics, then we will move on to the one chapter in science.
ಸೈನ್ಸ್ ಮಾಡ್ತಾರಂತ.
Tomorrow,
Electricity,
science
sir.
class will be there, and the chapter that is going to be started is electricity from
Sir,
physics.
light,
Huh? So
light
it
is,
is in the order. First electricity,
Sir,
then
first
magnetic effect of electric current, sources of energy, got it, light, and at last human eye and colorful one. We will cover in the same order. It is the guidelines given by the Central Board of Secondary Education, that is CBSE board. Followed?
okay, sir.
Okay. Now, please listen my instruction. Last instruction. While coming tomorrow, you just read the first 3 pages of the chapter electricity. So I'll send the PDF of that electricity chapter. And tomorrow, please get ready with your science notebooks, physics, chemistry, and biology. So with this, shall we now stop the class?
Yes, sir.
Okay, sir.
Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.